See here, the diagram which what we have discussed now just now is the basic biasing circuit. All the values are fixed. You see the VCC is a power supply, it is also fixed. Once you find RC will be fixed, RB is also fixed, VC is also fixed, so everything is fixed. Okay, so it is a basic biasing circuit and I need not worry about changing the components at all, because once I find out the values of RC and RB using Kirchhoff's voltage law, I can easily fix the values and I can ensure that I need not touch the circuit again for changing the value of resistance or voltage source. Only if VCC is going to change, all these parameters will change. But since VCC is fixed, everything is going to be constant. And you see here, we are focused, we are more bothered about the output side, right? So I'll be applying KVL at the output side. So output side means consider this, assume this CC and RL is not there, apply KVL in this path at the collector side. So can anybody say how many voltages are there in the output side of the collector in the BJT, in the basic biasing circuit, what you see? What are the voltages present in this path, in the outputs, in the arrow mark, what I have shown here? What are the voltage sources available? What are the voltage sources available at the arrow mark, what I have shown in the diagram? What are the voltage sources available?
12 volts, sir.
No. I'm just asking what are the voltage sources available in this path, what I have shown here. One is VCC, right? What is the other voltage available?
V out, sir.
No, I told you, don't worry about CC and RL. I have removed CC and RL because for biasing, I'll be considering only the transistor and the biasing resistance. Voltage is VCC. What is the other voltage available? It is between collector and emitter. This VCE will be available. This VCE is present here. So I have two voltages, VCC and VCE. What is the resistance I have in this path? What is the resistance I have in this path?
VCB, sir.
Resistance. RC. What is the current flowing in this path? IC. So what will be the Kirchhoff's voltage law equation along this collector side? See, always remember, when you consider the output side, you have to consider this voltage VCE. When you apply KVL at the input side, you have to consider the voltage VBE. And these two voltages will oppose your source voltage. They will be opposing VCC. So whenever you apply KVL, you have to put a minus sign for these two voltages. So the effective voltage at the output side is VCC minus VCE. Ohm's law, V equal to IR, right? So total effective voltage is VCC minus VCE equal to I. What is the current flowing? IC. What is the resistance in this path? RC. Okay, so VCC minus VCE equal to IC into RC. Or I can write VCC equal to IC into RC plus VCE. Anybody is not clear with this equation? This is the very, very basic equation we get when you apply KVL at the output side of your BJT. Anybody wants me to explain this equation again, or you're okay with this? See, these are the basic equations which you need to understand for biasing. We will be using this equation repeatedly again and again in all the problems. So anybody is not clear with this equation, how I got this KVL equation at the collector side of your BJT? Are things clear? I once again say, see the output side. When you consider biasing circuit, ignore all the AC components and other external components which you have added. So I will not be including CC and RL. On the output side, you see one voltage is VCC, one voltage is VCE. Always VCE will oppose your VCC. So the effective voltage is VCC minus VCE. Using Ohm's law, V is equal to IR. So VCC minus VCE equal to the current flowing through this path is IC. The resistance in this path is RC. So I can write VCC minus VCE equal to IC into RC, or I can write VCC equal to IC into RC plus VCE. Very simple. Total applied voltage VCC is splitting across voltage across the resistance RC plus voltage across the collector emitter terminals. Kirchhoff's voltage law says sum of voltages should be additive, right? Total voltage should be split across all the components. Same way here also you see VCC equal to, it is splitting across this voltage. This voltage is IC into RC plus this voltage is VCE. So this is what I have in the collector side.